Let's factor some of the special cases. So let's start with difference of squares. What is the difference of squares? Well, if you got something like this, two brackets that look the same, one's a plus, one's a minus, you remember that when we expanded, 2x times 2x gives us 4x squared. Then you're going to have minus 14 plus 14, that gets rid of the middle term. And then minus 7 times plus 7 gives us 49. The same thing will happen here. I'm going to get up with x squared and then minus 25. Because plus 5 minus 5 will take away. So in general, our general term would be a minus b times a plus b is a squared minus b squared. What do you notice about all these terms? Well, there are two terms. Both of them are perfect squares. What are perfect squares? Well, numbers like 1 squared is 1, so 1 is a perfect square, 2 squared is 4, 4 is a perfect square, 3 squared is 9, 9 is a perfect square, etc., etc. And we need to notice that there's always some subtracting. So if we keep those three questions in mind, then you will see that if you want to factor, let me put these questions here, if you want to factor the special case, that you could do it in any other way, but if you notice that was the wrong ones, if you notice that that's the case, then you can have a bit of a shortcut. So let's look at this one. The three questions are there two terms? Yes. Are they both perfect squared? Well, this would be 3x, and that would be 5. So yes, are they subtracting? Yes, I'm done. All I need to know is that this is going to be 3x and 5, and I need to put a plus and a minus, and it doesn't matter which bracket you do it. So let's check this one. Is it two terms? Yes. Is this perfect square? Yeah, that's x times x, so that's x. 144, yeah, that's 12. Is there subtraction? Yes, so therefore this is just x and 12, x and 12, and I just put a minus and a plus in either one. It doesn't really matter. What about this last one? 2x squared minus 18. Are there two terms? Yes. Are they both perfect squares? Well, no. 2 and 18 are not. But I should remember that my first step for factoring is to use common factor. So if I take a 2 outside, this becomes x squared minus 9. And what do you notice? Inside here, I do have a perfect square. Two terms. This is just x and 3. So that's going to be x minus 3 and x plus 3 right there. What about the last one? 4x squared plus 25. Are there two terms? Yes. Are they both perfect square? Yes, this is 2x and this is 5. Are they subtracting? No, it's not subtracting. So this is not actually a difference of squares. So it can't be factored as a difference of squares.